Hello, in this video we're going to be doing word problems where we have to both set up an equation and then solve for one of the variables. So the first example I'm going to do here, it says, it actually is one from our previous video, or at least very similar, where we set up a table of values, but this time we're going to try to just do it directly by using algebra to solve for the variable. It says it costs $158.05 to rent a compact car. The daily charges are $45.98. Write and solve a linear equation showing when the total charge will equal $433.93. From our previous video, we discussed how linear equations often have the form of a starting value plus some kind of rate times our variable equals an ending value. So that's what we're going to be using to set this one up. So the starting cost, no matter how many days I rent this car, is $158.05. So that's what I'm going to put for start. Then we have a rate, which in this case are daily charges. So that would be $45.98 for the rate, and then times X. And how they describe the rate here is an indication of what X represents. So since these are daily charges, X is the number of days. So we always want to define our variable in words in these problems. All right, so then it says write and solve a linear equation. Linear just means X is to the first power, which it is, showing when the total charge will equal. So now we're setting it equal to $433.93. So that's the setting up part, right? That we filled in all parts of the equation. We have the start, rate, and end. And now we want to solve. Solving is when we get X by itself. So anytime we see solve, that just means get the variable alone. And we've been doing this in class, just the numbers are a little messier now that we're doing real world applications. But it's the same idea that first we're going to undo this addition. And the opposite of addition is subtraction. So I'm going to subtract $158.05 from both sides. And these are definitely calculator problems, right? It's not designed to do, we could do this sort of by hand, but it is all right to use a calculator. So on a calculator, I did $433.93 minus $158.05, and I got $275.88. So last step to solve for X is to divide both sides to undo this multiplication that's here. So I'm going to divide by $45.98 because that will get X alone, and that's really our goal. And then if we put this in a calculator, it ends up coming out perfectly to 6. So then the question is, well, 6 what? When these are real life examples, we should be definitely labeling units, if not writing an entire sentence about what we found. And so in this case, it really helps that we put X's number of days so that I know that this is 6 days. So what I would say is that the total charge will be, and then it's that number that we were setting it equal to, $433.93, and then it's after 6 days. That's what we're really finding. Let's try another one of these. Example 4 says Mark has a weight loss plan where he intends to lose 7 pounds per month. And right away, this per month is making this a rate. So that's what we're going to put in for rate in our equation. And I often like to write out the form of the equation that we're going to be using, which is start plus rate times X equals the ending value. So I know my rate is 7, and we know that because it says 7 pounds per month, and the per month also tells us that X is representing the number of months. So paying attention to units in these problems will help us identify where everything goes and what everything means. Then it says his current weight is 232 pounds. That sounds like a starting weight, right? So I'm going to put it in for start. 232. And his target weight is 180 pounds. So that sounds like an ending amount. And at this point, maybe you notice that something is different here, where it doesn't really make sense for me to start at 232 and to add 7 pounds each month to get to that target. So what we neglected is that this is a weight loss plan. So what loss does is it makes a negative rate. So there's a negative rate for a loss. So I'm going to make this a negative 7x. The other way to think about it is that to make this subtraction. So that's because we're losing weight in this case. All right, so now it should work out. And if we hadn't put this negative in there, the x value we'd get is like some kind of negative value, and that wouldn't work for a number of months too. So, if something gets set up wrong, you often with the answer, you can tell that something went wrong too. But hopefully we sort of notice, oh yeah, this should be a negative because it's losing. So now I just solve it like normal. I'm going to subtract 232 from both sides. But now what's left is negative 7x on the left side. And on the right side, again, we're allowed to use a calculator on these. I got negative 52. Actually, that one's not too bad to do in our heads. And so because we changed that to a negative 7, now a negative divided by a negative makes the answer positive, which we definitely wanted. And this one, when I put it on a calculator, I'm going to use those approximately symbols for x. I got that x is approximately 7.43. Again, we should write out what that means. And so I wrote out that x is months, and so this is months. And then write a sentence about that. So that Mark will reach his target goal, his target weight. Target weight after 7.43 months. All right, and of course, that's an approximation. It's sort of around 7.5 months, but it's not bad to have a couple decimal places. Months does not have to be a whole number, so we want to keep a couple decimals on that. Great. Well, so we did a couple of these problems with the start plus rate times x equals end. Some of the other application problems we're going to see in section 2.5 will give us the formula. And hopefully this should make it easier, but let's see. This one has a little geometry in it. It says the perimeter of a rectangle is given by this formula. A garden bed has a perimeter of 28 feet and a width of 4 feet. What is the length? So first up, I always like to rewrite the formula. That always helps me, especially when these formulas are part of like a big paragraph. It really helps me to just put it down there. This one wouldn't be so bad just to write below, but I think it's good practice just to write it down. And then we want to read through what the problem tells us. It says the perimeter is 28 feet. So I'm going to write P is 28 feet. Again, so I'm just getting information out of the problem. The next thing it says is a width of 4 feet. So it sounds like W is 4 feet. And then it asks for us to find the length. So I like to remind myself what I'm trying to find, which is the length of this rectangle. So now I've written down everything that I need from this paragraph so I don't have to read it again. And what we're going to do is substitute into this equation. So we know that P is 28. So where there's a P, I'm going to put a 28. Now we don't know L, that's what we're trying to find. But we know that the width is 4. And this is a linear equation, again, because everything's to the first power. And after we substitute in the two variables that were given, we're left with one variable as an unknown that we can solve for. So first thing I'm going to do is do the 2 times 4. So that would be 28 equals 2L plus 8. And then we can subtract 8 from both sides. Always undo addition or subtraction first. So that's 20 equals 2L. And to undo multiply by 2, we divide by 2. So that would be 10 equals L. Now, because this is an application problem, we should use units and write a sentence. So if we notice over here where we talked about our variables, we used feet for perimeter and width. So that means the length is also in feet. And so I'm going to say that the length of this rectangle, is 10 feet. Great.